Imagine gazing up at the sky on a warm summer day. The sun is shining brightly and the air is filled with the gentle hum of nature. You find a comfortable spot on the grass, lie down, and look up. The sky is a vast canvas of blue, dotted with fluffy white clouds that seem to float effortlessly. Fluffy white shapes drift effortlessly, constantly changing and morphing. They take on different forms, sometimes resembling animals, sometimes faces, and other times abstract shapes that spark your imagination. It's like watching a slow-motion dance, a performance by nature that never repeats itself. These are clouds, floating masterpieces of nature. Each one is unique, a transient work of art that exists for just a moment before transforming into something new. They add depth and dimension to the sky, creating a dynamic backdrop for our everyday lives. They spark our imagination with their whimsical forms and inspire awe with their sheer size and power. Children point and laugh seeing dragons and castles in the sky. Adults pause to admire the grandeur of towering storm clouds, feeling a sense of wonder and respect for the forces of nature. But have you ever stopped to wonder, how do clouds hold all that rain? These seemingly weightless formations can carry vast amounts of water, enough to drench entire landscapes. The transformation from fluffy white clouds to dark rain-laden ones is a fascinating process. Clouds are more than just beautiful objects in the sky. They play a vital role in our planet's ecosystem. They regulate temperature, distribute water, and even influence weather patterns. Without clouds, life on Earth would be drastically different. They are a crucial part of Earth's water cycle, a continuous process that sustains life as we know it. Water evaporates from the surface, rises into the atmosphere, and condenses to form clouds. These clouds then release the water back to the surface as precipitation, nourishing plants, replenishing rivers, and filling lakes. Understanding how clouds form and hold rain unveils the fascinating science behind these celestial wonders. It's a delicate balance of temperature, humidity, and air pressure. Tiny water droplets or ice crystals come together to form clouds, and when they become heavy enough, they fall as rain. This intricate dance of elements is a testament to the complexity and beauty of our natural world. The journey of a raindrop begins long before it falls from the sky. It starts with a process called evaporation. The sun's warmth heats the water in rivers, lakes, and oceans. This heat transforms the liquid water into an invisible gas called water vapor. This water vapor, lighter than air, rises into the atmosphere. As it ascends, the air temperature drops. This cooling effect causes the water vapor to undergo a transformation. It changes back into tiny liquid water droplets, a process known as condensation. These newly formed water droplets are incredibly small, much tinier than a grain of sand. They are so minuscule that it would take millions of them to fill a single teaspoon. Despite their tiny size, they play a crucial role in the formation of clouds in the water cycle. Individually, they are invisible to the naked eye. These droplets are so small that they can only be seen with the help of a powerful microscope. They float around in the air, unnoticed, yet they are everywhere, surrounding us all the time. However, they clump together around microscopic particles floating in the air, such as dust, pollen, or even sea salt. These tiny particles act as nuclei, attracting water droplets to them. As more droplets gather, they form larger and larger clusters. As more and more water droplets congregate around these particles, they form a visible cloud. This process is known as condensation. The droplets continue to merge, growing in size until they become heavy enough to be seen as a cloud in the sky. The cloud appears white because the water droplets scatter sunlight in all directions. This scattering of light causes the cloud to reflect all colors of the spectrum, making it appear white to our eyes. The more droplets there are, the denser and whiter the cloud becomes. The process of evaporation, condensation, and cloud formation is a continuous cycle, constantly moving water between the Earth's surface and the atmosphere. Water evaporates from oceans, lakes, and rivers, rises into the atmosphere, condenses into clouds, and eventually falls back to the Earth as precipitation. This cycle is essential for maintaining life on our planet, providing fresh water for all living organisms. Clouds are classified into different types based on their shape, altitude, and the weather conditions they signify. Learning to identify these cloud types can provide insights into the current and future weather patterns. Some clouds, like the fluffy cumulus clouds, often indicate fair weather. Others, such as the dark and towering cumulonimbus clouds, are harbingers of thunderstorms and heavy rain. Section 5. High above us, cirrus clouds. High in the atmosphere, above 20,000 feet, reside the wispy and delicate cirrus clouds. Composed entirely of ice crystals, these clouds often appear as thin, white streaks across the vast blue canvas of the sky. Cirrus clouds are often associated with fair weather, but they can also signal an approaching warm front. Their presence can indicate changing weather patterns in the coming hours or days. Section 6. Mid-level majesty, altostratus and altocumulus clouds. In the middle levels of the atmosphere, between 6,500 and 20,000 feet, we find altostratus and altocumulus clouds. Altostratus clouds appear as gray or bluish-white sheets, often covering the entire sky. They can bring light rain or snow. Altocumulus clouds, on the other hand, are characterized by their white or gray patches, arranged in layers or rounded masses. They often create a dappled effect on the ground below and typically indicate fair weather. Section 7. Harbingers of storms, cumulonimbus clouds. Towering high into the atmosphere, sometimes reaching over 50,000 feet, are the mighty cumulonimbus clouds. These behemoths of the sky are responsible for the most dramatic weather events, including thunderstorms, hail, and tornadoes. Cumulonimbus clouds are characterized by their dark, anvil-shaped tops and often bring heavy downpours, strong winds, and lightning. Their presence commands attention and serves as a reminder of the raw power of nature. Section 8. The dance of condensation and evaporation. Inside a cloud, a continuous dance between condensation and evaporation takes place. As warm, moist air rises into the cloud, it cools and condenses, forming more water droplets. At the same time, some of the water droplets within the cloud evaporate back into water vapor. This delicate balance between condensation and evaporation determines the cloud's size and whether it will grow or dissipate. When the rate of condensation exceeds the rate of evaporation, the cloud grows larger and heavier. Section 9. From cloud to rain, the precipitation process. This fascinating journey begins high up in the atmosphere, where clouds form from tiny water droplets and ice crystals. These clouds are the birthplace of all types of precipitation. As a cloud accumulates more and more water droplets, they collide and merge, growing larger and heavier. This process is known as coalescence. The droplets start as microscopic particles, but as they bump into each other, they combine to form larger droplets. Eventually, these water droplets become too heavy to remain suspended in the air. The force of gravity begins to pull them down. This marks the beginning of precipitation. The droplets that were once floating high in the sky now start their descent towards the Earth. Gravity takes over and they fall to the Earth as precipitation. This can happen in various forms, depending on several atmospheric conditions. The journey from cloud to ground is influenced by the temperature and humidity of the air they pass through. The type of precipitation that reaches the ground depends on the temperature of the air through which the water droplets fall. If the air is warm, the droplets remain liquid and fall as rain. However, if the air is cold, the droplets can freeze and fall as snow or hail. If the air is cold enough, the water droplets freeze into ice crystals, resulting in snow or hail. Snowflakes form intricate patterns as they fall, each one unique. Hailstones, on the other hand, are formed when droplets freeze and are carried up and down within the cloud by strong winds, growing larger with each cycle. If the air is warmer, the water droplets fall as rain. Rain is the most common form of precipitation and is essential for replenishing freshwater sources on Earth. It nourishes plants, fills rivers and lakes, and supports all forms of life. The entire precipitation process is a crucial part of the Earth's water cycle, ensuring that water is continuously cycled between the atmosphere and the surface. Section 10. The life-giving cycle continues. Once the rain reaches the Earth's surface, it replenishes rivers, lakes, and oceans, starting the water cycle anew. This continuous movement of water between the Earth's surface and the atmosphere is essential for life on our planet. Rain provides the fresh water necessary for plants to grow, animals to thrive, and humans to survive. It nourishes our ecosystems, shapes our landscapes, and sustains life as we know it. Section 11. Clouds, a constant source of wonder. Clouds, with their ever-changing shapes and captivating beauty, serve as a constant source of wonder and inspiration. They remind us of the interconnectedness of Earth's systems and the power of natural processes. Next time you gaze up at the sky and marvel at the beauty of clouds, remember the intricate science behind their formation and the vital role they play in sustaining life on our remarkable planet.